Our first lesson is going to be on limits. So what I want to start out by doing is just talking about how you write and talk about limits. So I want to first address how you would read this statement right here. The limit says x arrow c f of x. This says the limit of f of x as x approaches c. You can also say the limit as x approaches c of f of x. What is a limit exactly? Well, it's really asking a question, and the question is, what's its expected height? So what is the expected height of f of x as x gets extremely close to c? And you have to look from both directions, from the right and from the left, unless c is an endpoint. We're going to see this visually here in just a little while. But let me just address a little bit about expected height. A speed limit is the expected speed that you would expect to go on that road. However, some people go over or under. It's just your expected speed. Just like a limit is your expected height. It may not be the actual height of the graph at that specific point. It's just its expected height. And so you guys, every time you read the limit, you really need to say to yourself, it's really asking me not what's the limit, what's the expected height. When you have this little plus sign after it, it's saying what's the limit, or what is the expected height as x approaches c from the right. So if you have some graph and you have a dot right here, from the right would be this direction, so from the right. If you have the limit as x approaches c with a little minus sign, that is saying, so this one is saying from the left. So as you approach that point from the left, this would be your c value. What is its expected height? The next thing I want to talk about is if you address those 2 points, from the right, from the left, okay, and you find that the limit is the same, they're both L's, well then if you go from the right and the left, notice how there's no distinction, there's no plus or minus here, then that limit also has to be L. Alright, to understand this more, let's get into some graphs, and then you can go back and re-listen if you weren't quite understanding what I was talking about because you haven't seen any examples. So what I've given to you is this huge graph f of x, and there's just tons of dots, open circles. This right here means that the dot is not included, but then the graph starts there and continues on. The colored in dot means it's included. So what we're going to do is run through a bunch of these problems, and you're going to continue to see the same graph the whole time. So what we're going to look at first is 2. The limit as x approaches 2 from the right. This is from the right. Okay, so we're going this direction from the right. What is its expected height? Not what is its actual height, what is its expected height? Well, the expected height is 1. So we're talking about height, we're talking about the y values. Then the next question says, find the limit as x approaches 2 from the left. Well, from the left would be this direction. What is its expected height? Well, that is also 1. So this is from the left. Now if we talk about from both sides, so from both sides, okay, from the right and the left, what is its expected height at 2? The answer is 1. But now the tricky question, what is its actual height? That's what f of 2 means. What's its actual height at 2? Notice how it's not a colored in dot. So since it's not colored in there and there's no dots above or below, we have to say that f of 2 does not exist, and we'll just use D and E for that. Moving on to the same picture, yet what I've done is I've just changed the number down here to now say 3. We're going to be looking at when x is 3. So as you approach 3 from the right, so from the right is this direction, what is its expected height? The expected height is 1. Now if I look from the left, that's this direction, as I approach 3, what's its expected height? It is also 1. The next question says, from both sides, from the right and from the left, what's the expected height? That is 1. And then, what is the actual function value at 3? Well, this is colored in dot. It is 1. Alright, so we're going to continue to work with the same picture that we were in the last video, and we're going to continue to talk about those expected heights, those limits. So in this problem, I'm now looking at 5. What is the expected height? What's the limit as x approaches 5 from the right? From the right, the limit would be 1. This one from the left, my expected height is 1. From both sides, so from the right and from the left, what is its expected height? That is 1. And then we talk about what is the actual function value here at f of 5, and it does not exist. Same picture, different point I'm looking at. So now I'm going to be looking at 1. So as I approach 1 from the right, what's my expected height? It's 1. From the left, as I approach 1 from the left, what's my expected height? Well, that's 0. Notice how from the right and from the left, the expected heights are different. Whenever those expected heights are different, we are now going to have to say that the limit does not exist at 1 because they are two different expected heights from either direction. They are not meeting up. And then on 16 here, it's asking me, what is the function value at 1? There is a function value at 1, even though the limit does not exist. The function value is where the colored in dot is. So there's a colored in dot right here. So the f of 1 value is 1. I have a few more of these, and I continue to use the same graph over and over, so you could just copy this one graph one time. We're going to look at the value 6 this time. From the right is this direction. From the right, my expected height is 3. From the left, my expected height value is 2. And now from both sides, from the right and from the left, the expected height does not exist. However, the function value at 6, the function value is where the colored in dot is, the function value is 2. So once again, we had a limit that does not exist because the limit from the right and the limit from the left went to two different spots. Alright, on this next part, I mentioned this way back in the beginning in video 1, but I said the limit from an endpoint can only be tracked from one direction. The solution in this case is the limit from that one direction. So I've got two endpoints in this problem. One of them's at 0 and one of them's at 7. So as you approach x, as x approaches 0, the expected height is 1. And as x approaches 7, okay, its expected height is 4. So those would be the solutions to those limit questions. Now moving on, I'm going to show you some problems like you would see in your assignments that you'll be working on independently. One of those is to fill these charts out. And this is simply to use a calculator and fill in the charts. So it's going to make you practice typing things into your calculator. When you type things into your calculator, which I will not be doing on this video, you will be putting in, well, what is my f of 1.9? So that means I'm putting 1.9 in for my x values up here. And when I do that, 1.9 squared minus 4, this is what I would plug or put into my calculator. I will go back and fill in this chart during class then. On this next problem that you would see would be from the book number 18, and what it's asking you to do is to find this limit. So it's the limit as you approach 1 from the right and from the left, and they do give you a graph, and here's the function in mathematical terms. They didn't make you graph it. So if you look from the right and from the left, your expected height is 4. A lot of you are thinking, well, the answer is 2. Right there's the dot. But this dot right here tells you what f of 1 is. F of 1 is equal to 2, but that doesn't mean that the limit equals 2. Its expected height from the right and from the left is 4. 2 more of those. This one is number 20 as an example. It's asking you to find the limit as you approach 5. Well, as you approach 5 from the right and from the left, notice how those two lines, okay, this one, I'll highlight it, goes that way, this one goes this way, they're going to 2 different expected heights. Whenever something goes to 2 different expected heights, the limit does not exist. And the last one here for today, the limit as x approaches 0 from the right and from the left. Well, from the right and from the left, the limit, the expected height, happens to be 1. Bring your questions to class, and we'll discuss any of the issues that you were not clear on in the videos.